Alright guys, today's goal, the learner will understand the fundamental theorem of algebra. The fundamental theorem of algebra. If f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Remember, complex numbers deals with real and imaginary, okay? If f of x is a polynomial of degree n where n is greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, each solution repeated 3 times is counted as 3 solutions, and so on. So repeated solutions are considered more than one. Okay, so let's take a look at an example. How many zeros do the following functions have? Okay, well, identify the degree. Degree is 5. That means this has 5 zeros. Okay, identify the degree. Degree is 2. So that means this has 2 zeros. Real, imaginary, repeated doesn't matter. We're just identifying the number of solutions. Okay? Alright, let's take a look at what we're going to do next. Okay, so if you look, it says find all the zeros of the polynomial function. X to the third plus 7x squared plus 15x plus 9. So this is what I did. Now, there is a way you can do this, but I'm trying to save us some time here. So, see how I graphed it? And I used the calculator to find some zeros? Okay, so watch. I'm going to choose this 0. X equals -3. And then what we'll do is use synthetic division. So you go -3, and then 3, 2, 1, 0. So you have 1, 7, 15, 9. Bring down the 1, -3, 4, -12, 3, -9, -9, or 9 plus -9, 0. So now we have x squared plus 4x plus 3. Okay? So now we think factor to finish, because you go equals 0. What multiplies the 3 and adds to 4? Positive 3, positive 1. So you get x plus 3 equals 0, x plus 1 equals 0, x equals -3, x equals -1. So see, we already found from the graph that we had one -3. Now we have 2 -3s and a -1. How many total zeros were there? Well, what was the degree? The degree was 3, so that means there was 3 total zeros. Did we find all 3 of them? Yes. Okay, so let's take a look at another example. Okay, so again, it's find all the zeros of the polynomial function. We have x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. So we know since the degree is 5, we need to find 5 zeros. If you look, there's only 2. So that means there's either some repeats or some imaginaries. We'll find out. Now, again, I use the graph. Use 1 to start. Okay? And then, so we know one of the zeros is x equals -2. So again, set up the synthetic division. So you have -2, 5, 4, 3, 2, 1, 0. 1, -2, 0, 8, -13, 6. Bring down the 1. You get -2. Add them together. You get -4. You get 8. 4 times -4 times -2 is 8. So you have 8. 8 times -16. -8. positive 16, 3, negative 6, 0. So now I have x to the fourth minus 4x to the third plus 8x squared minus 8x plus 3. Well, that's not very easy either, so we use the other 0 on the graph, right here. We use x equals 1. So you go 1, now you do 4, 3, 2, 1, 0. And you have 1, negative 4, 8, negative 8, 3. So you get 1, 1, negative 3, negative 3, 5, negative 5, no, positive 5, negative 3, negative 3, 0. Okay. So if I write this polynomial, so I have two of them still, so I have this polynomial. I have x to the third minus 3x squared plus 5x minus 3 equals 0. So I look, because that's not easy to factor either. You might be able to try factor by grouping, but that doesn't look good. So here's the thing. What that means is one of these two has to repeat itself. So see, there can only be an even number of imaginary solutions, like 2 imaginary or complex, 4 imaginary or complex. There can't be 3, 5, 7 imaginary or complex. So one of these two has to repeat. I'm going to try 1 just for the simple fact that it's easier to deal with 1 than negative 2 and do the synthetic division again. How do I know if it is? See how these times here, remember? See how the remainder is 0? When the remainder is 0, that means it is a 0. So, and then we have 3, 2, 1, 0. So now we have 1, negative 3, 5, negative 3. Bring it down, multiply, add, multiply, or add, multiply, add. See how we got a remainder of 0? That means x equals 1 is a repeated 0. So we now have 3 of the zeros because we can say x equals 1 again. So now we have this. X squared minus 2x plus 3 equals 0. Well, is there anything that multiplies to positive 3 and adds to negative 2? No. So that means you have to use quadratic formula. So we say x equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. Okay, so let's calculate that. So you should get 2 plus or minus the square root of negative 8 over 2. Okay? And so what does that mean? Well, we got to finish it now. So let's finish simplifying this. Okay, so you get 2 plus or minus 2i square root 2. Because remember, square root 8 can simplify to 2 square root 2 because it's square root 4 times square root 2. Okay? So then that would be x equals 1 plus or minus I times the square root of 2. So now look, we have these two, and then we also have x equals negative 2 comma 1 comma 1. And those three. There's the 5 zeros. Okay? So let's look at some more. Okay, so now we're talking about the complex conjugate theorem. If f is a polynomial function with real coefficients and a plus bi is imaginary 0 of f, then a minus bi is also an imaginary 0 of f. Suppose f is a polynomial function with rational coefficients and a and b are rational numbers, such as square root of b is irrational. If a plus the square root of b is a 0 of f, then a minus the square root of b is also a 0 of f. Okay, so here it says, let's look at the next examples here. It says, write a polynomial function of f of least degree that has irrational coefficients, a leading coefficient of 1, and the given zeros. So these are the given zeros. So what that meant was x equals negative 1, x equals 2, and x equals negative 4. Well, doesn't that mean that x plus 1 equals 0, x minus 2 equals 0, and x plus 4 equals 0? Because isn't that how we solve? So now, remember what we did when why did we set these equal to 0? Why did we set all these equal to 0 when we would solve going the other direction? Because we could factor them. So now you set it up. X plus 1 times x minus 2 times x plus 4 equals 0. So go ahead and multiply that out, and we'll get the answer. Okay, so if you need to catch up, press pause, but you should end up with x to the third plus 3x squared minus 6x minus 8. So there is your function. These were the given zeros. And what was the function that gave those zeros? This. Okay? All right. Let's look at the next question. So here it looks like they only gave you 2, but really they gave you 3, because remember, recall this. The irrational conjugate theorem. It says, if a plus the square root of b is a 0, then a minus the square root of b is also a 0. Okay, so what that means is we have a third 0. 1 minus the square root of 5. So you have x minus 4 equals 0, x minus 1 minus the square root of 5 equals 0, and x minus, erase, x minus 1 plus the square root of 5 equals 0. Now what I would do is I would multiply these two first, the two that have the irrational numbers, because the whole goal is to get rid of that square root at the beginning, not at the end. So when I write these down this time, I would go like this. Now just distribute x squared minus x plus x times the square root of 5 missed one. Now distribute the negative 1 minus x plus 1 minus the square root of 5, and then go for the last one. Minus x square root 5 plus square root 5 minus 5. Okay, we still have the x minus 4 there, so now what we need to do is just can't combine like terms. I only have x squared, so that's gone. Negative x looks like negative 2x. And then this is plus x squared 5 minus x squared 5, so those are gone. Minus square root 5 plus square root 5, gone. And then you still have minus 5. And then you have to remember to bring down the x minus 4. So I'm going to go ahead and pause and then finish this, so you guys finish this too. And press pause for right now. So this is what you should have gotten as your final function. Okay? Alright, let's look at a little bit more here. Okay, it says write a polynomial function f of least degree that has a rational coefficients, a leading coefficient of 1 and a given 0. So same directions, but here, this is going to be a long one. Here, see how it has the 1 imaginary and 1 irrational? That means we have to have the other imaginary, and the other rational. Okay? So what I would do is this. I'd do this in pieces. The first thing I would do, take care of the imaginary. So you'd get x squared minus 2xi plus 2xi minus 4i squared. Those cancel. Remember, I squared is -1, so that would just be x squared plus 4. So we got rid of that. Then I would take care of the x minus 4 plus the square root of 6, and the x minus 4 minus the square root of 6. Okay, so I'm going to press pause and finish this off. If you want to press pause and try to finish as well, go ahead. So that one simplifies down to x squared minus 8x plus 10. So now we have the x squared plus 4, the x minus 2, and the x squared minus 8x plus 10. So what you'd have to do is finish multiplying all that out, and I'll tell you what you get. If you finish multiplying everything out, you should get x to the 5th minus 10x to the 4th plus 30x to the 3rd minus 60x squared plus 104x minus 80. So I would recommend multiplying that out yourself and checking to see if you can do it, because that's something you should be able to do. Okay, so let's look at the next example. Okay, so we have 3 and 3 minus I. So remember, we need to do 3 plus I. So you get x minus 3, x minus 3 plus I, and x minus 3 minus I. So go ahead and multiply all those out, and if you do that, you should get x to the 3rd minus 9x squared plus 28x minus 30. I recommend you try to actually do this problem on your own and check to see if you get this answer. Okay? Please show work when I see the notes tomorrow. Okay. Now this next problem, this is where you're going to need to have a graphing calculator. It says approximate the real zeros for the following function. So it only wants the real. So you graph it, you find the zeros. So the 3 zeros for this are x equals negative 2.18, comma, negative 0.32, comma, 1.11. If you don't know how to do that on the graphing calculator, you need to come in after school or find someone, or probably there's a YouTube video or something, but you should know how to find zeros using a graphing calculator. See you tomorrow.